Okay, for this morning topic, we are going to discuss about kinematics. Okay, kita akan discuss tentang kinematics. So before this, we have discussed about Newton law, and today we are going to discuss about kinematics. What we can observe based on pattern and character. Right. For kinematics, it can be divided into two. One is linear, one is angular. So I'm going to touch both of these kinematics simultaneously, because these two things is actually the same thing, but the difference is just only towards the units being used and where you are going to measuring it. Okay, so kalau kata kamu tersangkut kejap lagi, just let me know lah, because there's a lot of things in here. Okay, first thing first, when we talk about kinematics, it tell you about pattern. Okay, pattern of movement. Apa lagi? Characteristic of movement. Apa lagi? Pattern, characteristic, motion. Movement lah. Okay, so pattern or characteristic in movement, we can divide into one is known as linear movement, another one is known as angular movement. Okay, yang ini kita dah cover masa topik type of motion, where in human, most of our motion is actually combination of these two, which give you general motion. Okay, yang ni dah sudah kan? Dah sudah ke belum ini?
Ya, awal-awal lah itu dah sih.
Dah kan? Okay, in linear we have two sub-component, which is rectilinear and curvilinear. Okay. So rectilinear ni pergerakan macam ni, pergerakan tegak. Curvilinear pergerakan yang begini, pergerakan melengkung. Okay, but not begini. If we go something like this, we are going to have another properties in the middle of it, which is known as axis of rotation. And if you have this kind of movement, this is an example of angular. Ada axis of rotation. Okay, itu yang asal, yang asas. Okay, alright. Next one. For all of this linear and angular kinematics, we are going to discuss about 3 to 4 things. Okay, the first one is about displacement. Okay, ataupun partner dia distance. This is for vector, this is for scalar. Okay, number 2 is about velocity, or partner dia speed. And number 3 is about acceleration. Enggak ada partner. Dia ni memang vektor semata, because acceleration have positive and negative. Means it has direction. So when the thing we can describe have magnitude and direction, that is vector. Okay, so kita akan bincang 3 benda ni je. These 3 things we are going to discuss in form of linear and in form of angular. Okay, ni yang asas. Beside these 3 things, we are going to add on some more, which is force. Okay, partner dia torque, Q-R-Q-U-E. And we have mass, partner dia moment of inertia. Benda aku hijau ni sekejap inertia. And then we have momentum. Partner dia angular momentum. Okay, this one is kinematic, this one is kinetic. So these are some of the things that we are going to discuss start from this week. Okay, because you need to know kinematic and kinetics, and you need to be able to show all of these things in your final project later on. Okay, so for today, we are going to discuss about the upper part of this of this information, which is regarding kinematic dulu. Distance, displacement, displacement, velocity, acceleration. Ini skala dia. Okay, yang ini untuk linear, ini untuk angular. Ini linear and angular serve the same name. It has the same name. Okay, so we go to the first one, displacement. Okay, displacement come from the root word displace. Maksudnya change of place. Okay, A to B, ada perubahan tempat, displace. A to B, ada perubahan tempat, displace. A and B at the same place. Dia bergerak macam mana? Dia bergerak macam ni. A bergerak, pusing, patah balik tempat yang sama. Tiada perubahan tempat. This is no displacement. Ni displacement. Okay. So in displacement, people always get confused with another term, which is distance. Okay. If we have two point A and point B, okay, and from point A to point B, the movement is something like this. Okay. If you measuring up all of this curve, this is known as distance. Linear distance. But if we talk about displacement, we want to know how much displace occurs. So for displacement, it is actually a straight line from point A to point B. The shortest route straight line, that is displacement. Okay. Tu konsep asas dia. If we go by curve, if we go following the pathway, that is distance. Displacement is the distance, okay, is the displace, the change of place between 2 point in the shortest route straight. Isu dia timbul bila kes macam ni. Katalah kita ada kes macam 400 meter. Okay, like 400 meter running. Okay. This is the first 100. This is the second 100. This is the third 100. And this is the fourth 100. So if a runner run from point A to point B, the distance covered is 100. The displacement of this point is also 100 because this one is a linear case, rectilinear. Issue dia sampai bila the runners continue running from from B to C. Now the distance covered is 200. However, the displacement is not 200. The displacement is between starting point to end point in the shortest route straight. Ke atas sana. Tu dia. So macam mana kita nak cari result, this displacement? This is R. So we need to have theorem Pythagoras. R equals to A square plus B square. Square root. Okay, if the runner continue running from point C to point D, the distance covered is 300. However, the displacement is this one. Straight line from A to D. Macam mana kita nak cari dia? Samalah dengan yang tadi. So we need to consult theorem Pythagoras. We need to find yang ini. Okay. If the runners continue running up until point A again, the distance covered now is 400. However, the displacement is null because now the runners is at the same spot where it starts. So there are no displacement at all. Ini displacement. Okay, this one is known as linear displacement and distance. Okay, boleh dapat? Displacement, distance, linear. Can you have it? Can you get it?
Sekejap, sir. Kenapa kita tak panggil displacement atau distance je? Kenapa kena ada linear?
Masa kejap lagi saya nak tunjuk angular.
Okay.
Konsep dia sama. Okay, konsep sama. So the concept here is displacement is the change of place. If it start and end at the same place, there are no displacement. Okay, itu yang pertama. Okay, good question. Kenapa nak kena panggil linear? Pasal ni case linear. Kejap lagi kita tengok case angular. Okay, itu yang pertama. Yang kedua, in linear case, linear displacement or distance, it being measured in meter. Okay, macam mana kita nak measure from point A to point B? How long that is the distance or displacement? Ni displacement. Kalau distance, we go all the way through the pathway. That is how we measure it. Distance and displacement linear. Okay, partner dia, displacement or distance angular. Bila kita cerita angular, you need to bear in mind one thing. It involve angle. Okay, it involve angle. So let's recap a bit about angle. Okay, angular motion, it will involve axis of rotation. When you see axis of rotation, you know that the motion is going to be around the axis of rotation. Ini pergerakan angular. Angular tak boleh jadi macam ni. Dia tak boleh pergi depan, dia tak boleh pergi atas, dia tak boleh. This is not angular. This is curvilinear. Because it start here, it end there. Move forward. This is linear motion. Exactly curvilinear. Angular, when you see angular, it will have an axis of rotation. Meaning that the motion will be surrounding the axis of rotation. Tak ada ke button kita boleh tekan hilang semua? Zas. Okay. So this is an example of angular motion. Example in human, such as kita punya hip. Okay, kita punya hip, kita punya lutut, kita punya ankle. So hip, movement dia macam mana? Movement dia macam ni. This is the axis of rotation, the head of your femur. And our knee, movement dia macam mana? Flexion, extension. Boleh tak knee ni bergerak ke depan? Can our knee move forward? Knee tu bergerak ke depan, pergi depan. Can our knee do that? We as a whole, yes, we can move forward. That is the reason why human motion is known as general, because the motion, the shape of the motion is linear. In order to produce that linear motion, we need to have rotation at the axis. Ini angular. So, ankle kita ada dorsal dengan plantar. Movement dekat mana? Axis of rotation. Knee kita, we have extend and flex. Move dekat mana? Axis dekat mana? Lutut. So, movement of angular is rotation. Okay? Rotation. Movement of linear is translation. This is known as translation. Okay, linear ni nama dia translation, pergerakan translation or moving forward, translate from one place to another. But movement for angular, it is known as rotation. Dia boleh pusing. Okay, itu yang pertama. So, to describe angular motion, we are going to describe in term of angle. Okay, jadi kita recap dulu. Whole rotation, full rotation will give you 360 degree. Ataupun we can name it as one rotation. Ataupun we can name it as one revolution. Or we can name it as 2 pi radian. Pi berapa pi? 3 point berapa? 3.14 ke 3.41? What is 3 point? 1.14. Okay, so value dia 3.14. Jadi 2 kali 3.14 kali dengan berapa? How much is 1 radian? 57.3 degree. Dapat tak? Okay, kadang-kadang kita kena check. 2 kali 3.14 kali dengan 57.3. Faham? 360. So, in order for you to describe rotation, dia kena ada begini. You can describe in term of angle, but in kinematics, we call it as, angle ni kita panggil dia sebagai datang ni. Nama kampung dia theta. Okay, nama kampung dia theta. Angle. Ataupun we describe in term of rotation. Ataupun we describe in term of revolution. Ataupun we describe in term of radian. Okay, kita describe in term of radian. Okay, why 1 radian equals to 57.3? This can be explained in a lot longer method, but I'm going to show you just a simple one. Okay, when we draw a rotation, okay, we are going to have radius kan. Ni daripada pusat axis ni sampai curvature ni, this is known as curvature. Okay, this is known as radius. Okay, radius. At 57.3 degree, A, B, and C is equal in term of length. Itu paling mudah lah untuk kita faham. So that makes 1 radian. 1 radian. Ni paling mudah untuk kita faham. Kenapa radian tu 57.3? You can Google that later. Okay, dia akan pergi sampai dia penuhkan semua ni, so you're going to end up dengan 57.3. There are some calculation, but I'm not going to burden you with that. You just need to know 1 radian is 57.3. That's all. Okay, ini unit dia. Okay, this is unit. Linear unit is meter. It being measured along the pathway. It being measured in a straight line. That is linear. Angular, it being measured in term of angle. Macam mana maksud dia? Maksud dia macam ni. When we talk about angular motion, let's say kan, kita ada lutut macam ni. Okay, this lutut start from 90 degree and then it goes extension. Okay, it goes extension. Now, it become 170 degree. Okay, so the distance covered by this movement is the change, which is 80 degree. This is angular distance. Means that we are going to seek the change of the angle. That is angular distance. Let's say kaki dia 90 macam ni. And then dia jadi 100. So how far that this the knee movement occurs? The knee move at 10 degree. So this one is angular distance. Look, it being measured in terms of degree. How many radian? You need to change that. Kalau 1 radian 57.3, 10 degree, berapa radian? Okay, so to further understand about degree, about angle, angular motion, kita akan bincangkan tentang pergerakan jam. Okay, 12, 6, 3, 9. Kamu bayangkan this jump as similar as this one. Ni. Okay. Now, if let's say, ni jarum minit. Okay, this is jarum minit. If this jarum move from 12 to 1. Payah ni 1. Move to 3 lah. Okay. The jarum move from 12 to 3. So, how far in term of angular distance the jarum had covered? Berapa jauh angular distance yang jarum ni cover sekarang? It goes here.
90.
Yes, 90 apa?
90 degree.
Yes. So, kita akan letak situ the distance is 90 degree. If the displacement dia berapa? Displace. How about the displacement? It's still 90 degree. If the clock hand move from 3 to 6, now what is the new distance?
180 degree.
Displacement?
Sama.
Sama. Sekarang tricky question. If the clock move again to 9, what is the new distance? 270.
70.
Displacement dia
90.
90, because this is the shortest route. Di situ. Okay. It's still in term of angle, yet the shortest route. If the clock hand further its motion to 12, now what is the distance?
360.
360. Displacement?
0.
0. Ini angular distance and displacement. This answer your question tadi lah. Kenapa dia linear kan? Because the unit is different. Okay, the unit is different. Yet, the way you explain about the nature is actually similar. Okay, cuma dekat angular kamu kena ingat satu benda. Whenever you explain about angular motion, in term of degree, always explain that in another form. So, we are going to pair the answer degree and radian. Selalu buat benda ni. Contoh yang pertama, the first movement, the degree is 90. How about the radian? How many radian? So, kalau degree kita nak tukar jadi radian, kita buat apa? 1 radian sama dengan 57.3. So, kalau 90 degree sama dengan berapa radian? So, you need to divide 90 with 57.3. How much you get it? 1.57. Jadi, for the first one, it is 90 degree ataupun 1.57 radian. Always answer angular case with degree and radian. Always do that. How about 180 degree? How many radian?
Pi.
57.3, 3.14 radian. Okay, pi radian. Okay, pi radian pun boleh. Pi radian. How about 270? How many radian? 270.
4.71.
4.71. Okay, 4.71 radian. 360? Tak payah fikir lah, 2 pi lah. Kalau dah bawah dia pi, atas dia 2 pi radian. Ataupun kalau kamu nak tulis figure radian tu, and then go for it. 3.14, 3.14. You're going to end up dengan 6.8 radian. Okay, ni cara untuk kita explain distance and displacement based on angular case. Okay, so kita dah ada linear distance, linear displacement, angular distance, angular displacement. The way to read those cases is similar from point A to point B. The shortest route for displacement. For distance, go all the way. Okay, yang tak sama hanyalah pada dia punya unit. Linear, we go meter. We go centimeter. We go millimeter. But for angle, we go degree, we go radian, we go revolution, we go rotation. Kadang-kadang dia naik apa ni? Dia naik rotation, kadang-kadang dia naik revolution. Dia macam tu. Okay. So this is some of the unit that you may have in angular. Linear tak susah. Kita ada distance. Saya buat macam ni lah. Saya buat kiri kanan terus. Okay, linear and angular. So the first one is distance. In linear, we call it meter. In angular, we call it dia macam ni. Ni ada dua simbol yang berbeza, but I'm not going to penalize you for that. Nama dia pi. Okay, nama dia pi, but somehow people always mix up distance and displacement. In displacement, linear still meter, but angular bulat dia sama, sengit dia lain, theta. Okay, but in most of the cases, people will actually taking this and translate that to angle. Jadi kalau kamu nak guna theta saja pun saya tak ada isu lah. Okay, People always use theta as angle. So when you see theta, this is when you see theta, this is the derivation of angle. Maksud nampak je ni, oh ni maksudnya angle. If people say theta is 30, means that the angle is 30 degree. Itu maksud dia. Jarang kita dengar kan, the pi is 30. Jarang-jarang. Okay, because it is actually the same unit, angle. Cuma angular case ni dia banyak benda yang berbelit-belit. So if you use theta, I'm okay with that. Okay, so this is the unit for linear and angular. Ini adalah properties pertama. Okay, this is the first properties in kinematics. Linear and angular. Okay, are you okay with that?
Okay, sir.
Okay, senang je kan? Kita pergi kepada properties kedua. Ni nota yang saya ada ni benar sama je. Nanti kamu tengoklah balik. Okay, this note serve the same purpose. Dia cerita displacement balik. Cuma notes ni, dia akan cerita satu-satu. Dia cerita linear dulu and then only they go angular. Okay. Asyik baik kita tengok notes. Okay. This is the same thing. Cuma dekat sini saya nak sentuh satu. Ni. Measuring angle. Okay. So to measure angle, we have two types. One is known as relative, another one is known as absolute. Okay. Apa itu? Relative. If let's say we take the same the example before, ni lutut ni. Okay. When we have two body parts, thigh, lower leg. Okay, when the angle is between two parts, this is known as relative angle. Okay, sometimes when we try to measuring angle, especially kita nak buat ergonomics punya analysis, contoh macam orang kat barang kan. Okay, we try to measure the angle of leaning. Leaning ke depan. Kita nak measure macam mana? We don't have two body parts intersect with one another. So, when you face this kind of analysis, we need to have one reference line. This is just an imaginary line. And this line need to have intersect with the body. So, we are going to use the line as the reference of the action. Jadi inilah angle dia. And when you use this kind of measurement, this is known as absolute angle. Okay, only use this one if the angle you don't have any subsequent body part, subsequent peripheral. Contoh kita nak buat pergerakan tangan. Okay, we want to measure how far the shoulder move. Jadi kita nak kita nak referencekan pada apa. Okay, shoulder movement. If let's say the elbow movement, it will be between humerus dengan radius ulna. Contoh, if you want to have kapal movement, we can actually have angle between the palm and your forearm. Okay, kalau kita nak buat pergerakan leher, kita nak tengok pergerakan leher kita, how much bend the leher can go. Kita nak referencekan daripada apa? We don't have any subsequent peripherals. If that the case, kita akan buat absolute angle. Means we are going to use, katalah leher kan, ni badan, kaki. Okay, kita nak tengok leher kita singit berapa banyak. So we are going to use one reference line which intersect with the part that we are interest of. Kita akan tengok dia punya leaning forward. This is absolute angle. Okay, so absolute and relative angle is the way for you to measuring angle, especially in human. How you want to read that? Again, similar as before. In terms of theta, in terms of angular distance, in terms of angular displacement. Okay, itu cara untuk baca dia. Alright. So second properties is about velocity. Okay, so velocity is the rate of displacement. Jadi bila dah nama pun rate of displacement, we have rate here, it involve time. ataupun t. So velocity in linear case is v equals to displacement over time. Kawan dia, speed equals to distance over time. This is a case of linear dululah. Okay, displace. Ni velocity. So we try to seek rate of change. A pergi B, berapa lama masa dia ambil. So we are going to get velocity. For example. Okay, katalah kita ada case macam ni. Simple street cases. The time taken for A to go there is 2 seconds. Okay, the distance covered from A to B is 5 meter. So what is the velocity? Jadi V akan jadi D over T ataupun 5 bahagi 2. Kita dapat 2.5 meter per second. Okay, in linear case, in rectilinear case, okay, in rectilinear case, distance and displacement is the same thing. Kena ingat yang tu. Kadang-kadang dia tanya, what is the distance? What is the displacement? What is the speed? Dia bagi displacement, but they ask about speed. You know that displacement talk about velocity. How can sometimes displacement become speed? It is when it is a straight line. Samalah distance 5 meter, displacement 5 meter. Tapi kalau kita ada case macam ni, okay, pergerakan macam ni, where B. Okay, so the distance covered here is 10 meter. Okay, it's 10 meter. The time covered here is, let's say, 4 seconds. Distance. Okay, so the question is, what is the speed? So the speed will be 10 over 4, 2.5 meter per second. What is the velocity? Bila dia tanya velocity, kita kena cari ini dulu sebenarnya. What is the distance between A and B in a straight line? Let's say curve is 10, straight line is 5. So velocity will be displacement over the time. Apa ni 5 bagi 4, kecil je lah displacement dia. 1.25 meter per second. You're going to get different answer if it involve different pathway. If the pathway is straight, distance and displacement is similar, resulting velocity and speed similar. But if the case is something like this, where the distance and displacement is not similar at all, you're going to get different figures for velocity and speed. Ini adalah velocity, okay, displacement over time. So why we need to find out velocity is about the rate of displacement. Okay, sampai sini. Okay? Okay kah? Enggak okay?
Clear.
Okay,
Clear,
sir.
clear Okay, kalau clear kita sambung kawan dia. We go angular distance, distance lagi. Angular velocity ataupun angular speed. Okay. Same as linear, where we have V equals to D over T. Angular, benda yang sama. Cuma, we are not calling it as V lah. Kita akan panggil dia sebagai macam W bulat. W is something like this. But this one is more round. Okay. Like an S. Tak disebut tu sebenarnya tu. Okay. This is known as omega. Omega representing angular velocity. Okay. Omega representing angular velocity. Kalau angular speed, kita ada benda macam ni. Bulat. Bagi dia tanda sikit. Tak lawa pula. Macam ni. Okay. This is known as sigma angular speed. Okay, omega angular velocity, sigma omega, semua omega dah. Sigma angular speed. Okay, if linear angular involving displacement and time, so omega also involving displacement. But displacement in angular, apa dia? Theta over time. Benda yang sama nampak. So kalau sigma, okay, sigma, kalau speed tadi distance over time, sigma it will be pi over time. Okay. Dapat tangkap? Ni, okay. Kalau linear, V equals to D over T. Distance over time. Displacement. In angular cases, displacement, mana? Displacement is theta. Saya dah tulis tadi, pi. Sekejap kat depan tu. Mana yang kita tulis theta tadi ya?
Ada saya dah tulis tadi. Pi.
Ada kan? Yang saya kata tak kisahlah kamu nak pakai mana-mana, distance ke, displacement. Ni. So, in angular, theta is displacement. Pi is distance. So, kalau kata velocity is displacement over time, in angular, velocity is known as omega. Displacement is known by theta, time tak ubah lah, time lah. Sama je. Kalau speed equals to distance over time, for angular speed, nama dia, apa ni tadi? Sigma. Distance dalam angular, pi over time. It is actually the same thing. Okay, people always get confused. Kenapa? Apa pasal angular keluar omega? Benda sama. The difference is just words, the shape, the name. That's all. Itu saja beza dia. Okay. So this is angular speed and angular velocity. This is angular speed. Okay. To understand this one, we are going to do the same example. Clock watch. Okay. 12:03. Now, what is the angular velocity for the clock hand to move from 12 to 3? Berapa angular velocity dia? Berapa omega dia? Can we find this? What is the theta for this movement? Berapa theta dia? 90. Okay, 90 degree. How about the time? Ni jarum minit. How many second does this jarum?
15.
15 minit. Second? Pasal. In linear, the unit is, tengok ni. So, when we talk about time, it is in second. So, unit untuk linear velocity is meter per second. Jadi, if the time given is in minute, you need to change that first to second. 0.3900, betul?
900, betul.
Okay, so 900. Berapa kita dapat? 90 bagi 900. 0.1, betul tak?
Sir, boleh tekan kalkulator macam biasa walaupun dia in degree?
Boleh. Sekejap lagi saya bagi tahu kenapa. Banyak pula 90 apa ni. Bagi 900. 0.1 kan? 0.1. Okay, now the unit. If you go like this, unit dia ialah dalam degree per second. Tu kalau unit dia. Okay, degree per second. Okay, sometimes we want to change this to radian per second. Kena tukarlah. 90 degree sama dengan berapa radian? 90 bahagi 57.3. 1.57 over 900. Apa kita dapat?
1.74 eksponen Negative 3.
0.0017 jauh tu. 0.00174 radian per second. It actually depends on unit yang kamu pakai. Kalau kata case kita macam ni kan, this is just an angular case, it doesn't really matter. Later on, we are going to see where we try to have relation between linear and angular. If this is the case, you need to use radian. Pasal radian ni means when we talk about radian, it is translation between angular kepada linear. So the case is linear for radian. If you talk about angle, it is totally angular. Contoh kan, kita ada benda macam ni. Later on lah kita ada benda macam ni. Kaki sepak bola. So this kaki, the motion is angular. This bola travel is linear. Okay, kita akan ada benda ni. Okay, kita akan ada benda ini, and this relationship, saya tulis kat sini dulu. Okay, linear kita ada velocity tadi, angular kita ada omega. To relate these two, we are going to use equation V equals to R omega, where R here is the radius of rotation. R. Bila case begini, this omega need to be explained in term of radian. You need to change the degree into radian first before embark in this particular equation, or else result dia mengarut. Pasal degree tak equal dengan meter. Radian equal dengan meter. Okay. Okay kah?
Okay, sir.
Okay, kita tengok contoh satu lagi Setelah kita ada pergerakan squat. Okay, kita ada pergerakan squat. Lukis gambar. Saya tak kerti lukis gambar orang squat. Okay, let's say lutut. Okay, this is full squat 90. And then dia naik atas. So bila dia naik, it become 170. Okay. So untuk dapat full squat, after dia naik, dia akan turun balik. And it become 90. Okay, dapat bayang benda ni? Can you imagine this one? From lower position, raise up and then go lower back. Kita tengok satu je dekat lutut. So the change, how much distance for this movement at the knee? How much distance covered by the knee for one squat? 90 pergi 170, we have 80. 170 pergi 90, we have another 80. So in order for one full squat to be conducted, the distance covered is 160 degree. How about the displacement for one full squat? Berapa displacement? 0. Okay, 0. Okay, let's say this full squat, okay, in order to make one full squat, the time taken is 3 seconds. Okay, so I need you to find out 1, sigma dia berapa, 2, omega dia berapa. Can you do that? So sigma equals to pi over time, omega equals to theta over time. Pi dia berapa? 160 time 3 second. Theta dia berapa? Kosong time 3 second. No omega. Pasal dah tak ada displacement. Okay, how about this one? 160 over 3. 3 kali 5. 15. 10. 5. 3.3. 3. Tak habis kan? Apa unit dia? Jangan lupa. Degree per second. Ni cara untuk kita kira velocity and omega and also sigma, or angular velocity and angular speed. Okay, this is how we do it lah. Okay, sampai sini dulu. Dapat?
So, kalau soalan minta distance dengan displacement, dia tak ada apa-apa simbol kan?
Simbol, maksud simbol macam mana tu?
Macam theta ke pi. Maksudnya dia akan tanya macam distance or displacement. Lepas tu kita
Kadang-kadang dia tanya macam tu, please calculate the angular displacement. Kadang-kadang dia terus mention, please define omega.
faham je.
So it depends lah, kalau nampak omega dekat situ dah tentu case angular lah. Kalau dia dah sebut angular displacement, omega lah tu. Cuma don't stop here. Okay, always don't stop here. Change this one to radian. Berapa radian? Kita dah ada degree, nak tukar jadi radian. 53.3 bahagi 57.3, 0.93 radian. Barulah kamu settlekan dia punya jawapan. Okay. Okay, kat sini. Okay, so I give you another example. Interrelation. Now we have V equals to D over T, and we know that omega equals to theta over T. Okay, so case macam tadi. Kita ada case manusia sepak bola. Put kaki ke belakang ni. So, this fella kick a ball, resulting the ball to travel. Okay. Katalah, we assume, rotation at the hip, the rotation occurs at the hip is 180 degree, and this rotation, this is dia punya theta. Okay, this rotation occurs in 0.5 saat. The time taken is 0.5. Okay, so the question is, what will be the velocity of the ball? Ni adalah isu interrelation, where in order to do this, we need satu lagi benda, which is radius. Mungkin dia akan bagi tahu the length between, kalau kita besarkan gambar ni kan, the length between femur ni towards heel is, berapa panjang kaki kita? 1.4 meter. So you know R equals to 1.4 meter. Can you find out the speed of the ball, the velocity of the ball? Cari ni dulu. Okay, kita cari omega dia dulu berapa. So V equals to R will be 1.4. Omega kita belum ada. Omega will be 180 over 0.5. Bolehkah kita selesaikan begini? This is interrelation case. Can we solve this one? No. Okay, you cannot. Change this one first to radian. 180 equals to apa? 3.14. Okay, so kamu kena tukar dulu, pasal case ni adalah case relation between linear and angular. So you need to change the degree to radian dulu. So you have 3.14. Barulah kamu selesaikan. 3.14 divide with 0.5. We have 6.28. So we have 1.4. 6.28 times 1.4, we have 8.79 meter per second. So by having this velocity at the hip, we can have a ball that travel 8.79 meter per second. Ni interrelation between linear velocity and angular velocity, between V and omega. This is how we play around lah. Kadang-kadang dia bagi tahu, okay, javelin tu bergerak pada sekian kelajuan. berapa laju tangan rotate. Contoh macam tu. Ataupun bola bowling travel at certain velocity. So, how about the rotation at the shoulder? So, rotation shoulder, angular cases. Ball moving forward, linear cases. In order to include all of those, kita akan pakai this equation. Velocity equals to radius omega. So radius dia adalah radius dekat shoulder lah dekat sini. Badan dia. So radius rotation dekat shoulder ni. Okay, this is how far is this one. Tu penggunaan. Later on kita akan tengok dia punya contoh. Okay, kita settlekan dia punya konsep dulu. Can you get the concept?
Sir, kenapa kena tukar dalam rad ni?
Dalam rad, okay. Degree, unit ni dia tak matching dengan meter. Because this unit still talks about things in rotational. Radian talks about things linearly. Jadi kita kena tukar unit yang sama lah. Kita tak boleh nak samakan anjing dengan kucing. Although anjing dengan kucing dua-dua kaki 4. Okay, so we need to make sure kucing tu, kucing Parsi dengan kucing kampung, and it's okay. Tu radian dengan meter. Means those two being translated in a linear case rather than in angular case. Itu je sebab dia. Okay, jadi bila kita nampak interrelation between these two, this interrelation is not only towards velocity. Later on kita akan tengok interrelation untuk acceleration. Same goes. We need to change the degree towards radian first. But if the question asks you about radian, about angular cases all the way, pakai degree pun boleh because we have degree per second. We have unit for that. But when we try to have relation between linear case and angular case, convert this first to radian. Barulah kamu dapat jawapan yang betul. Kalau tak, dia mengapu nanti. Okay. Okay, so kita dah sampai mana ni? Kita dah settle sampai angular velocity. Okay, angular velocity. Okay, lepas tu lepas ni kita akan masuk angular acceleration dengan linear acceleration. Mana linear? Ni jauh kat belakang. This one, linear acceleration. Alright. Can we proceed? Kita proceed satu dulu, lepas tu baru kita take 5. Boleh?
Boleh sir, boleh.
Okay. So the third properties is velocity. Velocity lagi. Acceleration. Acceleration. Linear case, acceleration is, we can call it as the rate of velocity change. So when we talk about rate, it can be positive, it can be negative. Where A positive representing acceleration, meaning increment of rate, while negative showing deceleration or decrement of rate. Okay, kita ada satu bola. Okay, katalah this arrow representing the velocity. So this ball will go like this. Means it increase the velocity. Acceleration. Positive. Sampai sini kita ada dia jadi perlahan. This is known as negative acceleration ataupun deceleration. Means if the ball, okay, let's say the ball start at 2 meter per second. After acceleration, it will become 8 meter per second. After deceleration, it becomes slower, 5 meter per second. This is the case of acceleration. Okay, so acceleration cause changes to velocity. Either the changes going to increase or the changes is going to be decrease. If the changes increase, it is positive acceleration ataupun acceleration lah. Kalau dia decrease, it is negative acceleration ataupun deceleration. Ni konsep. Okay, it happen to both angular and linear. So ni konsep linear. And this concept can be translated into A equals to V final minus V initial over T final minus T initial. V final will be, kalau kata kita ambil dua case ni, this will be V final, this will be V initial. V selepas is V final. Katalah kita tukar pula, kita tak nak ambil case ni, kita nak ambil case yang kedua. Between yang ini dengan yang ini. So this one will serve as V initial, this one will serve as V final. Same goes as the time. Time here is the time final, time here is the time initial. Or sometimes dia tak bagi time initial, time final pun. Dia bagi tahu je. The progress happen in 3 seconds. Meaning that this change happen in 3 seconds. So automatically the lower part kita akan masukkan 3 terus. Maksudnya dia dah bagi dah change of time berapa. So you don't need to measure anymore. But if you don't have the change of time, you need to seek that acceleration occurs in how many time. Tu adalah bahagian time dia. Okay, ini case linear. Alright, like this one. Kita terus gunakan dia sebagai contoh. Okay, katalah this is the first case. Okay, kotak first case. This change occurs in 2 seconds. And bulat ni pula, second case. This case occurs in 1.5 seconds. So the question, what is the first acceleration value? Jadi kita kena ambil V2 yang ini. 8 minus 2 bahagi dengan time 2. Which is 6 over 2, 3. Unit will be meter per second square. Don't forget this one. If you forget this one, you just put it as 3 meter per second. This is velocity. Okay, this is velocity. So don't forget square tu. Or you can write the unit as these figures. 3 meter per second. Sama. Ni bahagi 2. Ini meter bahagi saat. Ini meter kali saat. Tapi dia akan ada negatif. You show that the second is underneath. Okay, for the second one, A2, now V2 is this one. 5 minus V1, 8 over 1.5. We have 3 over 1.5. The answer will be negative 2 meter per second square. Bila nampak case kedua lagi kecil pada case pertama, dah boleh faham. Dah the figures will be negative. Kalau case kedua lagi besar pada case pertama, we know that is an acceleration, a positive one. Okay, jangan lupa ni negatif. So you have negative 2 meter per second. This is acceleration. Linearly. Okay. Okay? Okay kah?
Okay, sir.
Okay. Sekarang kita masuk kawan dia. Kawan dia sekarang ada banyak. Banyak. Okay, kawan dia ada banyak. Sekejap Kita ambil yang asas dulu and then only we go to the derivation of it. Okay. So we go to angular acceleration. Case for angular acceleration is similar as velocity. Kalau kata linear acceleration, A equals to V2 minus V1 over T2 minus T1. Angular acceleration, huruf dia lebih kurang, but it is known as alpha. Dia langkong sikit je, alpha. Okay, it is known as alpha. Alpha equals tu benda sama. Tadi velocity, angular velocity apa nama dia? What is the symbol for angular velocity? Datang ni. Apa nama dia?
Omega.
Omega.
Aja ulang balik je. Alpha equals to omega 2 minus omega 1 over T2 minus T1. Itu je lah angular velocity. Angular acceleration, sorry. So contoh angular acceleration ni macam ni. Let's say kita nak buat, okay, kita ambil larian. Kita ambil orang lari. Okay, kita ambil orang lari. Okay, rotation at hips. Okay, we take this rotation. Alright. Let's say during the first half of the event. This human rotational hip rotation recorded at 30 degree per second. Alamak, ini dah jadi peratus. 30 degree per second. Yang ni omega. And then after 5 minutes, we noted that the new angular velocity of the hip become 35 degree per second. Okay, and this change occurs in 10 seconds. So can you calculate dia punya alpha? Sama lah. This will serve as omega 2. This will serve as omega 1. So you have 35 minus 30 over 10 equals to 5 over 10 equals to 0.5 degree per second square. Inilah dia punya acceleration. So we know that based on these figures, we know that it increase in term of velocity. Katalah selepas seketika pula, it change. The new omega now become 15 degree per second. Kaki dia terseliur. And this change occurs in 20 second. 20 second. So what is the new alpha? Dia akan jadi 15 minus 35. Because this is the new complex. Equals to berapa ni? 15 tolak 35. 20 over 20. Equals to negative 1 meter per second. Dah jadi negative 1 meter pula dah. Negative 1 apa? Degree per second square. This is how we explain about acceleration in term of angular. Benda yang sama, but the unit will be differ. The place where we seek the information will be differ. Itu adalah angular acceleration. Okay, sampai situ dulu. Ada soalan? Any question? Okay, sampai sini. Ada apa-apa soalan dulu?
Tak ada, sir. Tak ada.
Ada. Okay.
Tak ada, sir.
Kalau tak
Boleh
ada,
follow.
kita akan take 5. After this, kita akan tengok dua lagi jenis angular acceleration. Okay, angular acceleration. Kita ada lagi dua. Yang tadi yang derivation sama macam linear. After this, we are going to see tangent acceleration dengan radial acceleration. We are going to take 5 and afterwards, we are going to seek some description about this thing. Angular acceleration. Ni dia. Tangent and radial acceleration. Right. Dah ready belum semua? Are you ready?
Ya, sir.
Dah. Baik.
Yes, sir.
Baik. Sebentar. Okay. So here, jangan tengok yang bawah tu, abaikan dulu dia punya formula. Kita ada dua formula kat sini. Just abaikan buat sementara waktu. Okay. I want to show you another concept of acceleration in angular. Okay. When we talk about angular movement dia mesti macam ni. Betul Rotation. But do you notice that sometimes we have rotation yang macam ni. Or sometimes macam ni. Kata. Means that the radius of rotation X and Y is not equal. X and Y. Macam ni equal. X and Y. Okay. So sometimes we may have this kind of movement. Sometimes we may have this kind of movement. Sometimes this one. Sometimes this one. Okay. Why there are change in terms of the shape of the rotation is because of these two acceleration. Okay. So tangent acceleration is an acceleration of this. Ni dia punya curvature ni. Okay, the acceleration is towards outside of the curvature. So every single point of this curvature have their own tangent acceleration. Okay, ni konsep dia. Acceleration which is towards the outside of the curvature. And this acceleration is actually sama ataupun linear acceleration. Okay, in other words, tangent acceleration, we can name it as alpha t equals to v2 minus v1 over change of time. Sama je dengan linear acceleration. Because it is linear acceleration from the curvature outside. So if the linear acceleration equal with another acceleration, okay, this at base of tangent acceleration towards the center of the curvature, we are going to have radial acceleration. Ataupun kita namakan ini sebagai AR. Okay, radial acceleration. V square over radius. Ni radial acceleration. Okay, so what is this two acceleration? Ni tangent acceleration. Component of acceleration of angular motion directed along a tangent. Along a tangent ni lah, along the curvature. Represent change in linear speed. So if tangent acceleration is equal along the way, we are going to have quite a smooth rotation. But if the tangent acceleration is differ, sekejap laju, sekejap perlahan, and then only we are going to end up macam ni. Okay, we are going to end up macam ni ataupun macam ni. Okay, to balance thing up, in order to make a smooth curvature, we have another acceleration that move inwards. Ni, yang ke dalam ni. Okay, that move inwards. And that acceleration is known as radial acceleration. Component of acceleration of angular motion directed toward the center of curvature. In other words, angular acceleration consists of these two. One is tangent, one is radial. Combining these two, and then only we are going to get this kind of acceleration. So sometime macam ni kan, macam ni, tangent acceleration dia besar. Okay, which causing curvature dia pergi lagi jauh daripada axis. Contoh kita ada axis kan, okay, dekat part ni tangent 10, radial 10. Tapi bila masuk depan ni, dia dah jadi lain. Tangent 12, ke dalam 8. Which cause the rotation or the curvature is not sphere anymore. It become ellipsoidal. Menjadi bentuk ellipse. Ni konsep dia, okay? And this ellipsoidal caused by unequal acceleration between tangent and radial acceleration. Okay. So tangent acceleration ini yang pertama. Bentuk yang pertama. Bentuk yang kedua dia, it can be equals to R omega over T. Okay, ni bentuk kedua dia. Itu dia. R omega over T. Since R ni adalah benda yang sama, kita boleh keluarkan R macam ni lah. R omega square dia over T. Okay. Kalau untuk AR pula, if we want to include we want to include the angular side, so dia akan jadi ni R omega. Okay, V ni akan ditukar kepada omega. So this one is going to be R omega square over T. Nampak bentuk dah sama kan? Okay, bentuk dia dah sama. R omega. Okay. Yang ini saya salah. R omega 2 minus omega 1. Okay, itu dia. Right. For AT, it will be R omega 2 minus omega 1 over T. Ataupun it can be V2 minus V1 over T. V2 minus V1 over T. Okay. AR equals to R omega square over T ataupun it can be V square over R. Tengok ada sedikit je perbezaan dekat situ. So, which one you need to use, it depends on the information that been given. Okay, it depends on the information that being given. And here when you seek omega dekat sini, the omega need to be in radian. Tu kena faham tu je dulu. Dia kena radian, dia tak boleh jadi degree because these two is derivation of linear and angular. Jadi dia kena radian, barulah unit dia sama. Okay, ni konsep asas. Saya try cari satu soalan yang ada kaitan. Acceleration. Okay. Alright. So let's try this one. Okay, katalah kita ada case of running tadi. Okay, we have a case of running. Dua case of running. Alright. So at first, this speed is 3 radian per second. And after 5 seconds, it become 2.7 radian per second. Okay. Yeah, after 5 seconds. Lama sangat 5. After 0.5 second. Okay. So the question is, what is the alpha of this one? Berapakah angular acceleration occurs at this stage? Okay. Omega 2 minus omega 1 over time. So that will be 2.7 minus 3 over 0.5. Berapa dapat? 0.3 bahagi 0.5.
Negatif 0.6.
Betul. Negatif 0.6 apa? Degree per second. So how many radian per second? Degree per second pula. Atas ni dah radian per second lah. How many degree per second? Kita kena tukar daripada degree pula. Okay, to convert radian to degree, 1 rad 57.3. So kalau 0.6 rad sama dengan 57.3 kali dengan 0.6.
154.71.
154 macam mana boleh dapat 154?
34.38. Salah. Lagi dia.
34.38 ataupun 34.4. 34 negatif 34.4 degree per second. Jauh sampai 100 lebih.
Oh, sir, boleh daripada kalau kita dapat jawapan right tu, lepas tu boleh darab dengan untuk tukar degree terus tak payah tukar daripada omega atas
Kalau kamu dapat jawapan, katalah kamu dapat jawapan 3 rad. Kita nak tahu 3 rad ni berapa degree. Darab je lah 3 kali dengan 57.3. Because 1 rad is 57.3.
Okay, faham.
Okay. Sekejap ni pasal apa ni? Omega. Saya nak cari acceleration sekejap. Okay. Kita ada satu hammer. This hammer is being accelerated at 15 radian per second square. Means that dia ada satu acceleration at 15 rad per second square. Okay. Katalah radius of rotation dia punya R equals to 1.7 meter. What are the magnitude of radial and tangential acceleration? Okay, dia suruh kamu cari AT and AR if, okay, when tangential hammer speed is 25, is if speed dia 25 meter per second. Maksudnya speed linear dia. If the speed linear is 25 meter per second and this hammer being rotated at an acceleration of 15 radian per second square with a radius of rotation 1.7, what is its AT and AR? Berapakah AT dengan AR? Okay, apa dia nak ni? Betul lah AT dengan AR. What are the magnitude of the radial and tangential? Betul lah. Okay. AR, AT. Ada satu lagi equation saya tak bagi kamu ni. Sekejap saya tengok equation. Ada satu equation yang saya tak bagi kamu. Okay. This equation. Relation between linear and angular acceleration. This is also known as tangent equals to R alpha. So kalau tengok daripada sini memang kita dapat jawapan terus lah. Okay, AT ni tangential acceleration, this one. Okay, tangential acceleration. This one is actually linear acceleration. Okay, this one is linear acceleration. And as any case of linear, when we try to inclusive radial or angular, contoh ni kan, linear acceleration, bila kita nak dapatkan in term of angular, kita akan tambah satu je, R. Same goes as V tadi, omega R. Same goes as displacement, D. Kita ada theta, R. So, by inclusive of radius, we have make a relation between linear and angular. So the question here is, find AT, find AR. AT is the acceleration at the curvature. So acceleration at the curvature, this one is A, ataupun linear acceleration. Jadi kita nak cari dia punya relationship, we have this. So AT equals to tangential acceleration equals to R dia berapa? 1.7, alpha dia 15. Direct kali 1.7. Kita dapat 10.5 apa? This is AT. So AT is in the form of linear. Jadi in form of linear, what does it means?
Meter second.
Meter per second. Betul. It is in meter per second. Saya salah darab ke? Saya salah darab ke kat sini? Sekejap nombor dah betul. Apa yang saya tertinggal? 0.7. No wonder. 1.7. Dah tulis pun boleh salah. Macam mana? 25.5. That is true. Meter per second. That is true. Because this is the case of AT. Meter per second. Ni jangan lupa. Jangan lupa. Meter per second square. This is acceleration. Okay. Number 2, we want to find AR. Jadi apa formula AR? AR equals to apa. V square over R. Ada tak? Tulis sini.
Ada.
V square over R. Substitute je lah. Okay, kita dah ada V. This is the speed. The V 25 square over 1.7. Apa dapat? 25 square bahagi 1.7 367.64 0.64 meter per second square. Apa maksud dia? Maksud dia, this hammer accelerated in tangent for 25.5 and accelerated inwards for 367.64. Quite high force here. Okay, let's try last one before we end the class. Sekejap yang ni nampak macam panjang sikit. 10, 12.5 period coming out of a curve. Curve 20 meter radius. What are the magnitude of radial, tangent, total? Cakap mampu semua sekali dia minta tu. Radial. Remember the vector component of total acceleration. 10, 12. Okay. Okay, kita ada ice skater. Ice skater speed from 10 to 12. Okay, kita ada ice skater, dia ada masuk curve je coming out of a curve. So we have a curve. Ice skater here and ice skater there. So at point E, ice skater speed is 10 meter per second. Okay, 10 meter per second. So this is linear. And then it changed to 12.5 meter per second. And this change occurs in 3 seconds. Okay, while coming out of a curve with a radius of 20 meter. So R value dia ialah 20 meter. Okay, the question is, what are the magnitude of her radial, tangent and total? Jadi kalau macam ni, kita akan ada satu tangent 80, satu ke dalam curvature AR, and then dia nak satu lagi sini. Total. So total tu saya bagi tips je lah. Total equals to AT square plus AR square, square root kan. Ni maksudnya kita ada benda macam ni tadi. We have AR, we have AT, dia nak total. Total acceleration. So they need to find out all of these three value. Okay. Apa lagi? Silakan lah. Apa yang kita ada kat sini? Apa yang paling mudah untuk kita cari dulu? It will be 80 equals to V2 minus V1 over T equals to 12.5 minus 10 over 3. 2.5 over 3 0.83 meter per second square. Okay, kita ada satu 0.83. Right, and then we need to find out AR. Okay, untuk AR ni, what are the magnitude of her radial, tangent and total acceleration as he leave the curve. So dia nak dekat sini. Okay, saya ubah gambar rajah ni sikit. They try to find out the figures here masa dia keluar ni. AT, AR, total. Okay, so AT kita dah ada. AR, berapa V dia dekat sini? 12.5. Tu AR dia. Equals to V square over R. Equals to 12.5 over 20 square. Square bagi dengan 20. So we have 7.81 1 meter per second square. Okay, kita ada AR dia 7.81 meter per second square. So kita dah boleh carilah total acceleration. Total A equals to 0.83 square plus 7.81 square root 0.83 square 0.69 plus square of 0.83. Okay, 7.81 square 60.61 lah. Malas tu bu. Okay, square root. So kita dapat apa ni? 61.69 square root 61.69 square root 7.85 meter per second square. This is here 7.85 meter per second square. Ini cara dia untuk kita gunakan the acceleration. Okay, so we have covered angular acceleration, we have covered tangent and radial acceleration, and also the interrelation between linear and angular acceleration. Okay, ada soalan sampai sini?
Okay, insyaAllah saya.
Tak ada. Okay. Saya tengok apa kita ada ni. Alright. Our notes have two more parts. The first part is from the linear, which is regarding ni. Okay, projectile. Ni kita akan sambung masa kelas Khamis. So, we are going to discuss this thing now. This is just a concept. Okay, terminal velocity dengan uniform acceleration. So, this is just a concept. First, we go with terminal velocity. To understand terminal velocity, it's this one. Mana saya punya pen? Okay, if an object falls down from a very high place, there will be one force acted upon the object. Apa force itu? Gravity. And the figures will be negative 9.81 meter per second square. Okay. And then, when an object falls down from a very high place, jatuh ke bawah, gravity tarik pada kelajuan ini. At the same time, there will be another force acted in different direction. And this is the friction. Okay. So, terminal velocity is something like this. Okay, saya bagi dia punya konsep. If you jump from a very high building, kamu akan ada acceleration. Betul? Kamu akan melaju. Betul tak? V equals to 10 meter. Certain, sampai sini kamu akan ada acceleration lagi. V equals to 20. Sampai sini kamu akan ada V equals to 30. Sampai sini kamu akan ada V equals to 100. Sampai sini V equals to 100. Sampai sini V equals to 100. You notice that when you reach a certain velocity, it does not change anymore. This is what we call terminal velocity. Okay, and why terminal velocity occurs is simply because when you reach a certain height, force of gravity will be equal with force of friction. Jadi figures acceleration ni dia akan naik. Acceleration plus, acceleration saya tulis dalam bentuk figures lah. Okay, dia akan menjadi macam ni. 20 jadi cos 10 jadi 20, kita ada increment 10. 20 jadi 30, 10. Towards here, 10 ni akan jadi 8, 7, 6. Belum. Here. Ni mungkin ada lagi acceleration 10 sampailah 100. Tapi dekat sini, acceleration kamu dah jadi kosong. Why dia jadi kosong? Because now the action that pull you downward is similar with the action that pull you upwards. Meaning there won't be any increment of velocity anymore. Ni terminal velocity. Okay. Downward force of gravity is equal with the upward force of drag ataupun friction ke atas. Sama. So kalau gravity 9.81, the drag will always be 9.81 at that particular point. So when you reach that point, net force on the body will become zero, resulting no acceleration, and the velocity will become constant. Ni dalam konsep equilibrium. That is what we call terminal velocity, means the most highest amount of velocity an object can have. And this can only be achieved when gravity value is equal with the drag value. So there are no more acceleration. So you are going to plummet down to the earth at the same velocity until melekat dekat bawah. Itu terminal velocity. Okay, maksudnya dekat sini, ni dah sama dah. Ni drag ni dah sama value. Kalau ke bawah 9.81, ke atas pun 9.81. Resulting velocity to be constant. So dia akan naik sampai satu tahap, dia tak akan ada perubahan lagi dah dekat velocity. This is terminal velocity. Okay, this is terminal velocity. Alright, second concept is about uniform acceleration. Okay, uniform acceleration ni mudah ni. Contoh, kita ada satu objek rolling down. Okay, kita ambil 3, 4 tempat. A, B, C, D. If the shape is permissible, what is going to happen is, at every single point of time, if you calculate the acceleration, A1 equal with A2 equal with A3. Means, kalau A1 ni 2 meter per saat, A2 pun 2 meter per saat, A3 pun 2 meter per saat, A4 pun 2 meter per saat, means every single second the speed is going to increase at the same rate. That is the concept of uniform acceleration. Uniform or constant acceleration is a type of motion in which the velocity of an object change equal amount in equal time period. Setiap 2 saat naik 1 meter per second. Saat keempat means dia punya speed tu equally increase. Bukan dia bukan macam ni. A1 2, A2 8, A3 5. There are fluctuation. This is not uniform. Means A2 dengan A1 dengan A2 mungkin bentuk dia macam ni. A2 dengan A3 mungkin bentuk dia macam ni. So the object is going to slow down a bit. This is not uniform acceleration. This is uniform acceleration. Okay, so an example of an object having uniform acceleration will be a ball rolling down a ramp, and this ramp gradient needs to be equal along the pathway, and then only you're going to get uniform acceleration. Itu adalah dua konsep dalam kinematik. Okay, terminal velocity and uniform acceleration. So that will serve as the end of our class, and we are going to continue with projectile during tutorial hours tomorrow. Okay, so if you have any problem, just let me know by our tutorial class tomorrow, and we are going to discuss about that again. Boleh?
Boleh, sir.
Alright.
Boleh, sir.
Nanti kita tengok sedikit soalan yang berkaitan dengan berkaitan dengan kinematics. Okay, again, thank you for your participation. Don't forget to take your attendance. Assalamualaikum and very good morning to everybody.
Thank you, sir.
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 Thank you, sir.